we have an island that is 1.1 mile due north of its closest point on a straight shoreline. So here's the island. Here's this closest point, which is a straight line. Okay. And then we've got a straight shoreline going this way. This is my cabin. This whole distance right here is 3.3 miles. So we're going to say that this is x, and we're going to say that the running part is 3.3 minus x. We know that we run at 5 miles an hour and we swim at 1 mile an hour. So running based on distance equals rate times time. We're going to divide both sides by the rate. So the time spent running is going to be distance over the rate. So we have the distance of 3.3 minus x over the rate of 5. Swimming is the distance of y over 1 mile an hour, but we want this in terms of x. So this is running as a function of x. This is swimming as a function of x, not yet. So we need to use Pythagorean theorem. So what we have is y squared equals x squared plus 1.1 squared, which gives me y equals the square root of x squared plus 121. Okay, so time as a function of x is going to give us 3.3 minus x over 5, which is the running portion, and then x squared plus 1.21 over 1, which is the swimming portion. Okay, so we're going to take a derivative. So our derivative of 3.3 goes to 0. Our derivative of negative x is negative 1, and that's going to be over 5. So t prime of x is going to be negative 1/5. You remember this goes to 0, this goes to negative 1, and 5's coming along for the ride. Okay, this derivative, we don't care about the over 1 because it doesn't change anything. So that derivative is going to be 1/2 times x squared plus 1.21 times the derivative of the inside, which is 2x. So this, negative 1/2, and this reduce. So remember, we want to set this equal to 0. So right now I've got negative 1/5 plus x over the square root of x squared plus 1.21 is going to equal 0. So I'm going to add 1/5 to the other side, which gives me x over the square root of x squared plus 121 equals positive 1/5. And now we are going to cross multiply. So when we cross multiply, what we get for an answer, let me flip my page, is going to be 5x equals the square root of x squared plus 1.21. There we go. All right, so I'm going to square both sides because I want to get rid of that radical. So I've got a 25x squared equals x squared plus 1.21. So subtract x squared from both sides, and we get 24x squared is 1.21. Divide both sides by 24, and I get 1.21. Hold on. 1.21 divided by 24 gives me 0.0505 or 04. So 0.0504166667. Okay, take a square root of that, and I end up with 0.2245. $3656. So that's what x is. Running is 33 minus x. Not 33, 3.3 minus x. So we have 3.3 minus that answer, and we get 3.075. So they need to run 3 3.075 miles. So the next time is the total amount of time that we're going to be doing this. Goes back to our time in terms of x equation, which was 3.3 minus x over 5 plus the square root of x squared plus 1.21 over 1. So all you need to do from here is substitute in our values for x. Okay, so for this one, we're going to get, what was x? We have this. Okay, so I've got 3.3 minus x over 5 plus the square root of 0.2245 squared plus 1.21. And we get 1.73778 hours. Okay? All right, we are given a length of wire that we want to, that's 8 feet long. And we want to cut part of it off, and so that it forms a circle, and we want to cut the rest of it, what's remaining, needs to form a square. So we have the circumference of a circle, which is the distance around the circle, is 2 pi r, which equals x. Okay, that's the distance around, so that's going to be x. And so when I divide both sides by 2 pi, I get r equals x over 2 pi. For my square, I've just got x minus 8 minus x divided by 4 needs to be the distance around my square. Okay, so hang on, now I'm deja vuing. Yes, it's a square. I was panicking there for a second. All right, so the area in terms of x is going to be the area of the circle in terms of x plus the area of the square in terms of x. So what is the area of my circle? It is pi r squared. What is the area of my square? It is side squared. So I'm going to turn around and I'm going to substitute this in. So do I know what the radius is? I do. It is x over 2 pi. So I have pi times x over 2 pi squared plus the side squared. Well, the side is 8 minus x over 4. So I've got 8 minus x over 4 squared. Okay. And then I am going to go ahead and square this stuff out. So I end up with pi times x squared over 4 pi squared plus 8 minus x squared over 16. Okay. That leaves me, once I reduce my pi's, with an x squared over 4 pi. And this leaves me with the exact same thing because I'm not going to multiply it out. Over 16. So that is my cleaned up area of my circle plus my square. So I'm going to take a derivative at this point. So my derivative here is going to be 2x over 4 pi plus, remember 16 is coming along for the ride. So I drop my 2 out front. So I have 2, 8 minus x to the first times the derivative of the inside over 16. So when I clean that mess up, I'm going to end up, this is going to be 2 over 4 reduces to 1 over 2. This is going to be over 8. And this negative right here, I'm going to bring out front as subtraction. Okay. So I have x over 2 pi minus 8 minus x over 8, and I want to set that equal to 0. So I'm going to add this negative chunk over to the other side. So I've got x over 2 pi equals 8 minus x over 8. I'm going to cross multiply, which gives me 8x equals 2 pi times 8 minus x. Sorry, you couldn't see that. I'll pause for a second while you catch up. Okay. And then I'm going to distribute my 2 pi which gives me 16 pi minus 2 pi x. And then I'm going to divide both sides by 8. Okay, so actually I've got x's on both sides, so I'm not going to divide by 8. Let's not do that. Since I've got x's on both sides, I'm going to add 2 pi x. So I'm going to add 2 pi x here and add 2 pi x here, which gives me 8 plus 2 pi x equals 16 pi. I can divide everything by a 2, so that's going to be 4 plus pi x. Where'd my x go? 4x plus pi x equals, divide by 2 is 8 pi. And then I can factor out this x right here. If you can't combine these, factor out. So I've got x is 4 plus pi. X times 4 plus pi is 8 pi. Divide both sides by 4 plus pi. So I have x equals 8 pi over 4 plus pi. So that's the value that I have for x. Now what you're going to want to do to find the minimum sum of their areas, and I'm going to let you do this because I'm in a hurry, to be brutally honest, is a sub x is going to be x squared over 4 pi plus 8 minus x squared over 16. And you're going to sub in this value right here for x here and for x here. And so just make sure you square it, simplify, combine like terms. And so that is it for that video. All right, a rectangle is inscribed inside of a right isosceles triangle. So if I turn this sideways, this is obviously not a right triangle. This is a right triangle. This is isosceles. This is isosceles. So these two things are the same length, which makes each one of the legs of the right isosceles triangle root 2 over 2, because the whole base of this thing is 1. Okay, so we really don't need the root 2 over 2. I was just kind of finishing it out. So I'm going to arbitrarily state that x is on this side. Okay, so I've got 0 is less than or equal to x is less than or equal to 0.5. So just to make it easier to see what this is, I put this on an xy coordinate plane. And so we have our xy coordinate plane right here. And so this has a height of 0.5, this is left 0.5, and this is right 0.5. Okay, so knowing that information, that makes the equation of this line right here, or this leg, negative x plus 0.5, because it's on a negative 1. Okay, and then the y-intercept is 0.5. So since P, where x comma some number, is on the line, so what we're looking for right here, okay, the y-coordinate of P is exactly y equals negative x plus 0.5. So as soon as we know what x is, we can fill in what y is. So the area of our rectangle is given to be, area is length times width. Our length right here is 2 of these x's. So I've got this part right here, and I've got this part right here. So that makes 2x. And then the height of what we're looking at, or the y-coordinate of what we're looking at, is negative x plus 0.5. Okay, so I'm going to clean that up a little bit and multiply it out. So that gives me a negative 2x squared plus x. And then I'm going to take a derivative. So the derivative of my rectangle's area is a negative 4x plus 1. set that equal to 0, subtract 1, negative 4x is negative 1, so x must be 1, you can't see, x must be 1/4. And that's probably the easiest one that we did in this entire section. Okay, so x would be 1/4 here, x would be 1/4 here for a total length of 1/2.